To begin our proceedings for today, I would first like to request Dr. Akhilesh Gupta to present the inaugural address. Dr. Akhilesh Gupta obtained his PhD degree in Atmospheric Sciences from IIT Delhi. He worked in India Meteorological Department, National Center for Medium Range Weather Forecasting and Disaster Management Cell of DST. Dr. Gupta has been the advisor to the Union Minister for Science and Technology and Earth Sciences. He has also served as the Secretary of UGC. Currently, he is heading Climate Change Program of DST, coordinating 2 national missions on climate change under National Action Plan on Climate Change. Dr. Gupta was a member of National Coordination Team, which drafted India's National Action Plan on Climate Change in 2008. Dr. Gupta is a fellow of International Academy of Engineering as well as of IMS.
Thank you very much for the introduction. Well, I think it is very misnomer for the duty that is given to me that I am supposed to inaugurate. Actually, I recall that this discussion that we are going today was, in fact, we had plenary discussion a few months back, and Jenny was here and Ashwani and many others, that how do we create a kind of a holistic picture on the climate services. So much is already given to you, so I am not going to repeat those issues like why we need climate services and all. It's all known, well known why we need climate services. The question remains that how do we build these services with the participation of not just government. In most of the services, when the word services comes, the first thing that comes into mind is that it is government focused. But that is not the case. Unlike weather services, which are totally government, is all like early warning system, forecasting, this and that. Climate services are somewhat different. And this is what we need to discuss today. There are several questions that have been already written here over the early climate session that will be discussed and that should be asked. But let me focus first on what are the priority areas for climate services. In fact, as for the global framework on climate services of World Meteorological Organization, there are originally 4 priority areas that were outlined: agriculture, water, health, and disaster management. And later on, energy was added. Now, these 5 priority areas, they all belong to a domain where the climate impacts are going to be realized. And in fact, some of these areas already you have evidences in India. We have done several studies are done by several institutions. The evidences are very clear that these impacts are already felt. Now, in order to build this services in this priority area, we had a discussion in India Meteorological Department some time back. We did in the process of establishing a full-fledged climate services. That there are 2 things that will build the climate services information system, and that is where, as I said, the government will need support of. One is, of course, observation. So you need observing system, and they are located in different parts of the country, linked with the global observing system and a monitoring system. Now, this obviously is the domain of government. Observing systems are mostly done by the National Weather Service or National Climate Services. But their, of course, role is there for private and NGOs and other, but it is largely dominated and controlled by government. The second part is research, modeling and prediction system, or what you call climate modeling and research system. Now here the lot is a very area where participation of many stakeholders really required. And this is of course driven by government, but participated by all kinds of people. Now DST has been implementing the two national missions on climate change as a part of National Action Plan on climate change, and these two are national missions for sustaining the Himalayan ecosystem and the strategic knowledge system. Under these two missions, we have set up as many as 150 Qurans, several center of excellence, major R&D Quran, network Qurans and all. I'm not going to elaborate on that. And the several sub-national level program, like we have 24 state level centers doing research at a very local level. Now the third component, which is also equally important in this thing, is the capacity building. The capacity building is again is supported by government, but it is driven by agencies in the all private sector NGO. We had very good experience. I'll tell you, we had at this state level, this 24 centers where we have the entire training program. As many as 1,50,000 people are trained in past 3 or 4 years, and they are driven by, they are conducted by, they are organized by the civil society organization and the NGO. Very well done. I think government cannot do like that. Very professionally done. Now, having said these things that I would want to mention, that there are, I would not go too much into detail because there are already other speakers, so I will restrict my comment on this thing, that there is urgent need for 3 kind of synergy and collaboration that we think. One, of course, it is true that government driven things had to be done for the climate services, but frankly speaking, even within the government there is no synergy and collaboration. So first thing is that there is need for interministerial synergy. Something of this kind is being done, but we need much more than. Second, collaboration is required interinstitutional, which is very important because that is. And the third is, of course, it requires a kind of wider network of people working in a thematic area, like health network we need agriculture network, we need network for the water and all, and the research network eventually will bring the right input for the climate services. And of course the government has to take lead, because unless they take lead, this cannot be synergized into a effective service. I think last but not the least, I would say that in this endeavor, the participation of community is very important, because that is the end where the dissemination of the services output will be required. And of course, where the participation of state government also into this thing will be very crucial. And DST, I would say that we are ready to support this endeavor, because very shortly, I think 22nd and 23rd March, we are organizing a national level debate on the operational implementation of climate services that is being organized by Indian Meteorological Society. on 22nd and 23rd March. It is on WMO Day. So with that, I'm sorry I might have taken a little more time, but I thought that we bring the kind of information that is required for the climate session. Thank you very much.
Next, I would like to invite Ms. Jenny Dessen for taking the event forward and introducing the speakers for today. Ms. Jenny Dessen is the Corporate Relations and Partnerships Lead at NCICS, where she facilitates collaborations and partnerships with private sector industry partners, government, academia, scientists, and others to understand climate information needs and applications on the adaptation timescale. She supports the Division Chief of Climate Information Services at NOAA's NCEI in various activities in their Regional Climate Services program. She has worked in the management consulting at Accenture, specializing in utility operations and deployment of large-scale business transformation initiatives through process improvement and technology enablement. The floor is yours.
Good afternoon, everyone. Thank you for being here. I'm quite pleased to be part of this panel and the series of talks we're having this morning. I will go a little fast and faster than planned, simply because we're already a little bit behind. So basically this talk, as you can see from what you will hear, we have sort of two key focus areas. In the first half, we have a series of talks and speakers that you see up there. And the second half will be a panel discussion. And the panelists I will also place up there so you can see their names. For the first part of this, we will hear a series of talks related to climate in the regions in India and the notion of working together in collaboration and applying climate information. And from all these talks, you will hear about needs, challenges, applications, issues, opportunities, all of those components. And please make a note of that, because the panel in the afternoon will further enhance those points, and we want this to be a discussion together. Okay, so with that, I'd like to begin with first introducing you to Saurabh Bhardwaj. He's part of TERI. I will not read his extensive and amazing bio, but as you know, he is a climate modeling expert, has been with TERI for a long time. And before TERI, he was a scientific developer. He comes with math and physics, and from what I just learned, he's also pursuing his PhD in mathematics. But is a climate modeling expert and has extensive experience in applying this information across different sectors. So Saurabh, it's all yours.
Thank you, Jenny. And as a co-organizer, I'll welcome you all for this very interesting thematic, where we try to basically merge together science as well as the user's perspective. So my talk would be I'll try to limit it in less than 10 minutes, would be primarily giving you a perspective of why we have to do modeling, why regional modeling is an essence of what we have been doing, and how it has actually helped few stakeholders and different types of stakeholders. So my context, I come from, in front of you are the AR5 images. On your left is a concrete evidence of warming happening, which is top left. But when you go to, the bottom left is the variability in the rainfall, which is not as straightforward as temperature. But what is straightforward is on your right is a direct evidence, and also for the future, where there is clear indication of rise as well as in the historical of extreme events globally that people are seeing, and in the future models also predict the same. When we talk of India, also on your left over here is a clear indication of warming happening in the past over India, but the rainfall is highly variable. But when you talk of the extremes, and this is a extreme rainfall, a higher rainfall, it has a very strong evidence of increases in the past. And also for temperature, there are increasing heat trends all over India that we have seen. In the future, yes, India shows a very variable picture for both, for especially for rainfall, which is over here. But for temperature, it also shows a very clear-cut increase as the global projections. And the extremes also, the the models are also showing a very clear-cut increase for the extremes. Now, when we have the science with us, ready with us, right? It's global models, then global models seen over India. But what was relevant for a user was, this doesn't concern us. The concern is what you can give us at our regional scales. What would affect my business if I am a business entrepreneur, or if I have a climate-sensitive business at my end? So that was first of our demands that we came to know 10 years back, started 10 years back, that there was an increasing demand from climate-sensitive businesses and stakeholders. And that came to, and then we came to a conclusion that these data sets that the model are preparing for the entire globe or for the entire India will not suit the purpose. We have to have a regional downscaling done. And that gave us few of the recent completed projects. On your right are some projects from the state of Himachal Pradesh and Punjab, where the government was interested in knowing what are the climate resilient pathways that our state should go forward with. So regional modeling products were used along with impact models and agriculture modeling products to give that kind of a policy-centric information to the government. Then came the government of the city of Visakhapatnam as well as Goa, and they were very well sensitive to the fact that the extremes are increasing, especially the coastal impacts are increasing. So how can science-based products can help them have a plan for climate resilient infrastructure services? And that came, and this project came into picture. And recently, which was a very interesting project, was for the first time in India, the oil and gas sector actually were interested in knowing how the climate change would affect their businesses. It was the other way around, because every time oil and gas sector were blamed for increasing the global emissions and all and the stuff. But this time, they were also interested in knowing how the climate change that is happening for the future would be affecting their businesses. So of course, it was a very big study. There were different kinds of assets, localized assets, pipeline assets, which cover vast areas. But the thing was, the background was a very evidence-based science that was used to present these kind of products. The second type of regional stakeholders that were there were the regional stakeholders or the state governments, which was as per the state action plans they wanted to make. So there, the science also was the first pillar or first pedestal where all the policy-centric outputs were given to them. So regional models were used at that level as well. And the third and the most interesting these days that you find are even local level stakeholders. When I say local level, these are at the level of urban local bodies, municipalities. They are also interested in having an action plan ready which has mainstreamed their climate. And I refer to a recent ongoing project, which is with the state of Telangana, which looks at the climate change mitigation and adaptation for the urban local bodies of Telangana. Now, if you want to go as high resolution as possible till the district, not even a district, even at the urban local body level, you have to have a very sound climate information available. And we'll be talking more on information towards the end. So this gives you an idea of how the interest and how the demand is changing. You have scale issues in the demand at the national level, state level, as well as at the urban local body level. But are these regional models any better? So what we are using is, we are trying to use a latest PRESI 2.0 regional model, which is based on its parent model of HAT-GM2 from the UK Met Office. And the regional model performs much better. It resolves the coastline much better as compared to to its parent model. These are the coastlines which are, and even if you see the extreme indices, which give you a signal of extreme behavior of climate for the future, the regional model is performing much better than its parent model. Also, if you see the time correlation, for the mean temperature, you see most of the places over India are bluish towards 1. So the correlation is matching well with the observation as compared to its parent model. And same goes for maximum temperature. so you can actually use this kind of science. You can actually use this kind of science to answer your questions at whatever level you wish to. And how you will be able to answer that, how these scientific outputs basically relate to the outputs that you would require. Like if I don't know why this is not working. So this was a image of animation of a storm hitting a coastline and how the indentation was happening. So such kind of inputs are available for the user to take. But how and how you can interpret is a different thing altogether. One thing is having a tool available to the policymaker at the regional level. And this is just one of the snapshots of what TERI Climate Tool is working on. It's a beta version for the state of Maharashtra. At particular location, you can you can use different model, and it gives you a kind of an assessment of how your particular area would change, how the climate would change at your particular area for the future. So what I'll do is I'll stop here, just giving you a glimpse of how the science, the data is being utilized at different scales, at different level, by different types of stakeholders currently, but still there is a lot more gaps to be filled up, which would be discussed here on. Thank you.
Thank you, Saurabh. That was a very nice introduction to getting a spectrum of data, tools, information needs, and applications both at a national and a regional level. So as I mentioned earlier, that this first part of the talk is really talking about climate impacts and data and uses and applications in the regions. And so one of these regions includes the northern region of India. And so with that, I'm very pleased to introduce you to Dr. Ashwini Kulkarni from IITM. She will be talking a little bit about what IITM Pune discussed at their recent workshop in October related to the Indian Himalayan range. So many of you know Dr. Kulkarni. She is with IITM Pune, is an expert scientist. She's also the project director, an expert in climate variability, climate change, climate prediction. Many of you may not know, but her PhD background is in statistics, which is really fun, and also has been an esteemed author, has lots of interactions with IPCC community, and so on and so forth. So, Dr. Ashwini, please tell us about what's going on in the Indian Himalayan range.
Thank you, Jenny, for my introduction. Well, in India, the region and the people who need the maximum of climate services in terms of climate applications, climate prediction, climate analysis, climate data management, climate research, all those things in the region of Hindu Kush Himalayan region. So I will talk in few words about climate projections and applications over the Himalayas. So if you look at the geography of this region, there are 10 major river basins which encompass the 4.2 million kilometer square area. It is also known as third pole of the world because out of the north and south pole, it is the region of maximum snow and glaciers. It is shared by 240 million hills and mountain people and shared by 8 countries and 1.65 billion people in the river basins downstream. So any type of climate variability or climate change is going to affect the livelihood of 240 million people. So climate variability and change is very important factor over this region. Now, considering the observed data, there is very less observed data available because of the hilly region here. But still, whatever observed data is available, the analysis shows that warming trend is more than average global trend and which is more accelerated in recent 3 decades. There is evidence of elevation-dependent warming. That is, as you go high in the mountains, the temperature warming gets more amplified in the region. The glaciers and snowfields of the HKH region, Hindu Kush Himalaya region, are found to be the fastest receding glaciers and snow covers in the world. And the rapid warming causes solid state water to shrink, leading to increase in meltwater, more frequent incidences of flash floods, landslides, livestock diseases, and other disasters in the Hindu Kush Himalaya region. So we can imagine if there is a slight climate change, what is going to happen over Hindu Kush region. So the region is undergoing rapid change driven by stresses such as climate change and human conflicts, and factors like globalization, infrastructure development, migration, tourism, and urbanization. So if you look at these temperature trends in Himalayan region, you can see that after 1980 or so, the temperature, mean temperature, top panel, is consistently warming. And if you look at the table, the trend in minimum temperature is more than trend in maximum temperature. And if I compare it with the global trend, based on the period 1901 to 2014, the global trend is 0.084 per year. So here in Hindu Kush Himalayan region, it is 0.104. And in the recent period also, it is more accelerated. So, and the minimum temperature is rising more rapidly than maximum. So the diurnal temperature range is also decreasing very fast over this region. So it is the observed fact, as all of them are showing red or yellow, that means they are decreasing or receding very fast. These are the observed facts. These are the glaciers of Hindu Kush Himalayan region. And these are the disaster risks increasing in this region. This shows floods, droughts, landslides, glacial lake outbursts, and floods. The light circles are number of people affected, and the dark circles are number of people died due to the floods and all those things. So, and even 1/3 of the disasters are floods, and many of them are crossing the national borders. So this is the major threat to this region. Now, Hindu Kush Himalaya is one of the hotspots of climate change. Now, what are the factors which are contributing to the climate change over this region? There are some natural factors, there are some man-made or anthropogenic factors, but natural variability, it is beyond our control. But in human-induced, it is densely populated, livelihood constraints, poverty and marginalization, high food deficit, constraints of infrastructure, and rapid urban growth. So these are the major factors who are making this Himalayan region at climate change hotspot. Now, there has been a special report of IPCC which says that if we want to adopt the Paris Agreement, the global warming should be controlled at 1.5 degrees centigrade above the pre-industrial levels. But even though the global is controlled at 1.5 degrees, over the Himalayan region, it will correspond to 2.1 degrees centigrade in this scenario even. And if we consider RCP 4.5, it is estimated that the rise over the Hindu Kush Himalayan region will be approximately 2.5 degrees centigrade. And if the current emission levels are continued, then the warming may be of the order of 5.5 degrees centigrade. So we can imagine what will happen to these glaciers and rivers and all those things here. Now, the best tool is to look into the CMIP 5 models, which are readily available to us. So this figure gives you the changes in temperature under RCP 4.5 in near future, 2036 to 2065, and in far future, that is 2066 to 2095. So we can see that if we go from near future to far future, the temperatures are warming, and even more than RCP 4.5, RCP 8.5 shows more warming. It is of the order of more than 5 degrees centigrade or so. Similarly, if we look at the changes in precipitation due to CMIP 5, we can see that over the northwestern Himalayan region, the rainfall is projected to be decreased, and whereas over the central Himalayan region, the increase is maximum. Over eastern Himalayan region, to the eastern side, there is an increase in rainfall, but less than that over the central Himalayan region. So these are some of the projections given by CMIP 5 simulations. As you can see here, this is the box plot, and what it says that the annual average temperatures top panel with respect to present day mean clearly show a consistent increase in surface temperature over the Himalaya region. Middle panel is precipitation, so overall the precipitation is also showing increase if we consider the entire Himalayan region. And the last panel is snow, so you can say that it is decreasing very fast under both the scenarios, and if we consider the CMIP 5 models. Now CMIP 5 are the very coarse resolution models, and as we know, over the Hindu Kush Himalaya region, the land cover changes every 10 kilometer or so. So if we look at the trends in precipitation, winter precipitation, you can see here that a top panel shows you the observed trend in winter precipitation using the Aphrodite data, and the bottom panel is trends using the CMIP 5 multimodal ensemble simulations. So you can see that the color shading is exactly opposite. Over Western Himalayan, observed shows increasing trends, whereas CMIP 5 shows decreasing trends. So the trends are not captured by this coarse resolution CMIP 5 models. Also, if you can see here, this is the time series averaged over the Himalayan region. So winter precipitation shows increase in trend, while CMIP 5 fails to capture that trend. So this is because of mainly the coarse resolution of the models. So we need to have the models which will capture these observed features reasonably well. Then only we can have some confidence in their projections. So under the WCRP, there is a program known as Coordinated Regional Downscaling Experiment. Some 14 global models have run the models at 50-kilometer resolution, and all these downscaled models are archived at our institute's website that is freely available. So if you see here, the top panels are the observed temperatures over Himalayan region. Second row is CIMI-5 simulations, third row is Cordex South Asia simulations, and the last one is the difference of biases between CIMI-5 minus Cordex. So if we have to, now these dynamically downscale models are computationally very expensive. And so if we run these models, we should have some added value to that. But if you see here, there is a very huge bias in Cordex South Asia models, and we don't achieve anything by reducing them to 50 kilometer from the CIMI-5 coarse resolution models. Similarly, the precipitation, if you see here, again, we can see that there are large biases in Cordex South Asia models. So again, we have to think of whether to use these Cordex South Asia models for Himalayan studies or not. So we go for statistically downscaled model, that is next GDDP data, which is global daily downscaled projections. And this is freely available to users. The site is given there. This is 25-kilometer resolution models. These are 21 models from CIMI-5, which are statistically downscaled by using bias correction spatial disaggregation method. And the daily near surface minimum maximum temperature and precipitation are the parameters available. So this is the global data set available. And if we see the simulation by these next GDDP models, we can see that the biases are much reduced as compared to the Cordex South Asia models. So at present, I will propose the next GDDP models give better representation of the Himalayan region. So this is the temperature simulation by next GDDP model. You can see that the biases are at the most -1 to +1. So they are much reduced as compared to the Cordex South Asia models. So considering this multimodal ensemble of next GDDP, we can talk about projected changes in summer monsoon rainfall over Himalayan region. So we can see that over the western Himalayan region, the rainfall shows decrease, whereas in central and eastern Himalayan region, the rainfall may increase by say 5 to 20% under RCP 4.5 and 5 to 25% under RCP 8.5. So you can see here how the various models give the projections in far future over Western Himalayan region, JJS rainfall. Some of the models show decrease, so there is not much consensus among the models, but multimodal ensemble top bars, you can see that they show the increase in JJS rainfall over Western Himalayan region. Then in Central Himalaya, there is much better position, many of the models are agreeing with each other, and so we can have much faith in their projections. So both of them are showing under both, all the models are showing under both scenarios, increase of the order of 30 or under RCP 8.5 and of the order of 20% increase in the RCP 4.5. Now under Eastern Himalayan region, there is 100% consensus among all the models, and so they show the increase of approximately 20 to 40% under RCP 4.5 and 8.5. So these are the possible projections. Now this is mean temperature change over the Himalayan region under RCP 4.5 and 8.5. So under RCP 4.5, the range is from less than 1.5 to 3, whereas if you look at RCP 8.5, the range of increase is 2 to 5 degrees centigrade. So in summary, I will not present anything about the extremes. These are also horribly increasing. There are more intense precipitation events and frequency is also increasing, but there is a time constraint. So in summary, CIMI-5 models project consistent increase in surface temperature and decrease in snowfall over Himalaya towards 21st century. However, we need to have high resolution simulations for better representation of weather and climate over Himalayan region. The projected temperature changes suggest that under both the scenarios during summer, there may be relatively higher warming over hilly regions of northwest Himalaya and Karakoram than in central and eastern Himalaya. Towards the end of the century, the rise in minimum temperatures may be more than the maximum temperatures in all the seasons, and precipitation may increase by 4 to 12% in near future and 4 to 25% in far future. So sustainable development goal is to take urgent action to combat climate change and its impacts. So this is the region where these people need our help to overcome these climate change impacts. So how we can do it? Understanding the past and potential future of climate change using various models over this region, we can better comprehend the present and future risks, help people to strengthen resilience and adaptive capacity in the face of climate-related hazards and natural disasters, and we can integrate climate change adaptation measures into national policies, strategies, and plans. Whoever is interested, I will recommend to visit this or read this Hindu Kush Himalaya Assessment Report, Mountains, Climate Change, Sustainability, and People, which is just inaugurated on 4th February by EC Mode. So this is a detailed analysis of climate change adaptation over Hindu Kush Himalayan region. So whoever is interested, you please visit the EC Mode site. You will get the first page, this report. Thank you.
So we cannot have any discussions about climate change, data, and so on and so forth without oscillating and shrinking back and oscillating. So if you just imagine, we were talking about climate in the regions, we had to talk about climate extremes. And so our next speaker is Dr. Krishna Ashutosh Rao, and he is going to take us out of the regions and back across the entire country of India, and he will give a national perspective on what's happening with extremes over India.
Okay. Good afternoon. Thank you for inviting me to be a part of this session. I'm just going to give sort of a flavor of the kind of work that we've been doing at IIT Delhi. So this is, I've got my 2 trustee students who've been working hard on this. So I have to acknowledge their contribution to this. So just to set the stage here, so we all understand that the climate services are absolutely essential for us to adapt to variability and change. And there's a reason why there's variability separate from change. In my understanding, the change is what we are inducing through anthropogenic activities, and variability is something that happens anyway. That doesn't mean that extremes only happen because of change, because extreme weather events have always occurred, even under natural variability. So it's important for us to understand that there's extreme events in a context where there's no change, and then under change that there's extreme events and what could happen to them. So we all know that the priority areas include these 5 things, as Dr. Akhilesh Gupta has already pointed out. Extremes, I think, have relevance for all of these areas. It's not just in a disaster context, it's also relevant for health and energy and food and agriculture. So that's another reason why extremes, I think, are important to focus on. And we all understand that the implementation of the global framework on climate services includes these things, and I come from the research, modeling, and prediction world, where we're not at IIT, not directly engaged in the climate services per se, but providing the research and modeling and prediction understanding is where I come from. So the extreme events we're looking at it in three sort of interlinked ways. The first thing is we are asking the question, as I've already mentioned, there were always extreme events of various kinds. Are extreme events that we are seeing over India influenced by climate change? Have they, for some reasons, made the extreme events worse, or maybe not affected, or made it better? We all know that cold waves are probably going to reduce in number under climate change, under warming. So that would be an example of something whose incidence or occurrence decreases over time. So this is what we call attribution of extreme weather events. And then the second question we want to ask is, how is the risk of such events expected to change under future climate change? And This is not just a projection per se, but also trying to understand it in a risk framework. And then the third question we ask is, can we predict such events, not on the weather prediction timescale where they tell you in the next 3 days you will have a heat wave, but under longer lead times, under climate prediction lead times. So I'll start with a couple of examples of work that we've done and published. One was with looking at the Chennai rain event in December 2015, which was widely acknowledged as the kind of extreme weather event that climate change will bring. The second one is the heat wave of 2015, where, as we all know and remember, many thousands of people lost their lives. So I'm going to dwell more on the second one, because what we have, and both of these were published in reputable places, but basically the point we were trying to make with the heat wave is that what we understand as a heat wave is not just a temperature that exceeds some level threshold or something. There's also a component of humidity involved, and we looked at whether accounting for changes in temperature and humidity is somehow giving us sort of a clue as to whether these kinds of high mortality from that event could be triggered from a combination of both the heat and the temperature and the humidity. So what we found, and this picture is sort of it's a classic NOAA classification of what might be danger, extreme danger, extremely hot. So these are sort of weather forecaster terminology as to what you might find. But the coloring is based on what might be considered danger, extreme danger, etc. in the US. Now clearly, if you look at a Hyderabad airport, all the red areas is where the May temperatures climatology lies. So if you considered NOAA's classification, this would be extreme danger to live in Hyderabad in May of any year. So that's the average year is extreme danger. So clearly within India we have to develop new sort of frameworks to understand what is dangerous, what is extreme danger, etc. But clearly what we've found is that if you were to look at the temperature distributions, and there's two histograms here, one is a red histogram and the other one is a blue colored histogram. If you look at the red histogram, that's what actual temperature distributions of extreme heat are, daily heat index are for that 2015 May time period over Hyderabad. Now if you look at the blue one, that's what the temperature distributions would have been without human-induced climate change. So clearly you can see that the distribution of temperatures has shifted to a warmer, at least 3 degrees or so warmer on the averages, but at the extreme points also. So a 3-degree increase in the heat index, remember this is not just temperature, this is also accounting for humidity, is a large amount. So this is one kind of analysis that we are doing. Going to the second part, whether we can understand how these things might change in the future, we looked at the Paris Agreement numbers. We looked at the 1.5 degrees and 2 degree numbers. Right? So these are the threshold targets that we examined. Now there was a project called HAPPY, unfortunately called HAPPY. It's an acronym that what we were looking for is not just 1 or 2 model simulations. So if you attain 1.5 degrees, in order for us to capture extreme events and the distribution of extreme events, we would need hundreds of simulations. Hundreds of simulations is what we got. We had we examined 500 simulations of the 1.5 degree climate and the 2 degree climate. And what I've plotted here is sort of the relative risk. So at 1.5 degree, how many times higher is the risk of an extreme? Now, this is what we defined as heat wave or severe heat wave is the definition that the IMD uses. So if we use the IMD's definition and not NOAA's, if we use that, then what we are seeing, if you look at all the red colors there, those are telling us relative probabilities. So something that is an orange color is 2 to 4 times more probable, and anything in the red is 4 to 10 times more probable in a future climate. Even at 1.5 degrees, we find large parts of India where the probability of a heat wave goes up 4 to 10 times. And we can see also that there are some patches of purple. Those are places where you never had a heat wave that lasted 7 days or 8 days or higher than that. So there are areas that never experienced such long drawn heat waves or severe heat waves that are going to start experiencing them. So this is something that we think is a message that is useful for people who plan and execute heat action plans, etc., to keep in mind. Because if you look at the duration of a heat wave, and if you're not a population that is normally used to such long heat wave durations, it's going to be extremely difficult to adapt to such things. So we come back now to the 2015 event. So here's what the duration of the heat wave was in number of days. You can see here that there were places that the heat wave was like 5-6 days, and then there were regions where it went up to 9-10 days. So this is how that 2015 heat event played out. So what we then tried to do is that we want to see whether this specific event, if we went back into our prediction models, right? There are predictions that are not just done in the weather short range or medium range or even in the extended range. We're now going into seasonal, sub-seasonal and decadal prediction models to see whether these models, if they are able to pick up these heat waves. And I'm just giving a couple of examples from 2 models which we looked at the seasonal, sub-seasonal to seasonal timescales. So all you have to focus on is the leftmost upper and lower figures, and those are the durations of heat waves that were predicted by these models a whole month before. Right? If you recall the previous slide, that was the pattern and the duration signature that we had actually experienced. But a whole month earlier, there were these 2 global prediction centers that were able to pick up those patterns and those durations of heat waves. Now we're looking at the S to D, which is seasonal to decadal prediction models, where again the idea is not that we look at this model and give a prediction that this is going to happen, but we will be able to look at a multi-member ensemble of these predictions and be able to give a probabilistic forecast that this summer there's likely to be one large heat wave of this kind with this duration in these regions, which I think is within the time frame of actionable information, and that's what we think. I've focused on this one heat wave because I think it's easier for me to speak with one focus. We are doing this across a whole range of different kinds of extreme weather events, including floods such as the Kerala one, and also looking at the Chennai flood kind of. So I'll stop here. Thank you.
In our regions and across India, there are extreme events that will create additional demand for data, information, climate projections. But I want to scale you right back, oscillating back down to our regions, and I invite now our next speaker, Ms. Anu Jogesh, who will be talking about some advancements that have been made in moving the needle, in making data information and data portals in a decision context, specifically in Uttarakhand. I've been working with Anu in a number of different contexts, but this particular example is one worth sharing with this team because it talks about the importance of collaboration and international partnerships and why it takes all of these components to bring data and information out and into the hands of the decision makers.
Good afternoon, everyone. As Jenny said, I'm Anu Jogesh, and I'm with Acclimatize. We are an advisory actually focused on climate risk management, climate resilience almost entirely, and have actually been working with the government of Uttarakhand now for over 6 years under different sort of programmatic and project heads. And this was a very interesting project where we were able to use some of the earlier work we'd done with the government at the governance scale, at the state planning scale, and take it to the next level in terms of mapping climate information. I'll start by saying that, and this is something that both, Saurabh has also sort of picked on, and Dr. Kulkarni has also picked on, that a lot of climate information, and now I'm speaking about very upstream climate information, a lot of the modeling data, but just climate data itself has been made by and driven for governments. Apart from the national communications submissions to the UNFCCC that sort of India initiated, the state climate planning process has been one of the largest government-driven efforts at driving climate information. We saw an example of what Terry's been doing with Maharashtra as well. And I say largest only because literally almost every state and union territory now has been mandated and has formed a state climate plan. And what actually happened is that a number of these states undertook climate vulnerability and risk assessments because, to start off with, what is a climate plan? A lot of the state governments sort of struggled with what is a climate plan? How do you sort of put it on the continuum of climate and adaptation? And almost ex post, actually, the vulnerability and risk assessments came about, which then used, some were based on perception-based studies on the ground, some were actually district-level model-based studies using various scenarios and timelines. And so a number of these states have actually developed these. But what's interesting is that there has been very limited in terms of attempts at applying these assessments and the climate information they encapsulate in bisectoral departments, to start off with where they were first aimed, but other sort of stakeholders that came together to make these plans, namely civil society organizations. The private sector, even less. Local businesses have not gotten really involved in the climate planning process itself. So one doesn't really expect that they would have sort of are aware of or know that vulnerability and risk assessments have been happening, though that is changing, and I will come to that. Some of the key challenges, of course, have been the larger overarching issue, and this goes beyond just the usage of climate information, which is the utility of it, and tied to the larger issue of the recognition of climate risk for that specific sector in that particular state. But what we found, and this was state to state, I mean, a number of states that we actually spoke with, was this huge gap in translating the available climate information, and what it implied for the various sectors in a format and language that target users could actually incorporate. The vulnerability and risk assessment for Uttarakhand are these 4 large 500-page tomes. And they literally sit with the nodal agency, and they have a lot of information, downscale data, multiple scenario analysis, and also using impact models for a number of sectors. But translating that to what an agricultural department can use, what the disaster management agency, or rather I'd say the disaster management agency is likely a little better poised, but what a mining department would use. It ties to the larger question of, are they aware of the state climate planning process? Are they aware of the nodal agency and what they're doing? And therefore, is there a way to translate the vulnerability and risk assessment into a context they can use? and of course the availability and access to credible data. And when I say credible data, I'm not even talking about model-based data. A lot of the vulnerability and risk assessments use proxy indicators for socio-economic data. And having access, departments who function in silos, getting that information, getting it aggregated, making sure it's credible information, that you do not have varying baselines for the data that you're actually using. And then the larger issue, which is an overarching issue that I think you will hear from Jenny, and you would see this in any country that's actually beginning to use sort of climate services in a little more progressive way than we are, which is just a few steps ahead, really, which is decision-making under uncertainty, which is if I have now managed to understand the utility of climate information, I have recognized climate risk, I have been able to translate this into a language, and I have some demand-based requirement for why I need climate information, whether I'm a local business or I'm the government, and I've had access to credible data that is actionable. The huge question is, the data that actually comes out is under RCP 4.5 for precipitation for 2050 in Uttarakhand. Precipitation may actually increase to -5 to 12%. Under 8.5, it would be, 8 to 25% increase. How do you work with that information? How does a government department work with that information? I'll move specifically to Uttarakhand because this is exactly what happened. The action plan was developed, it was endorsed by the government of India. There was immediately a need felt for a vulnerability and risk assessment because they realized that a lot of these plans did not prioritize specific sectoral actions, and there was no climate evidence base to prioritize or even cost. A lot of the incentive actually was for finding funding. The next step is what we undertook, which is we realized immediately that there were these large 500-page 4 tomes. So how do you align what were in these sort of VRE assessment documents to what it meant in terms of implications for specific sectors? For instance, if the VRA said that the return period of a flood would be X and the probability of that in a certain scenario would be X percentage, unpacking that, what that meant. What is a 100-year return period? What does that mean in terms of, for the energy department, in terms of hydropower generation, in terms of minimum water flow for irrigation, and of course for infrastructure? What it meant if a 100-year return period flood appears in terms of frequency, the frequency of that actually increases. So we developed these, and therefore, when the opportunity to came about for the Partnership for Resilience and Preparedness, which is PREP for short, came about in terms of a pilot for this project in India, it was a fantastic way to bridge some of these gaps. Sort of take what you have, you've made implications. Now, can you take that to the next level? Because you're still having an issue with departments not accessing that information. Now, PREP, just stepping back from Uttarakhand, is a global public-private collaboration. It started in the US in 2016. It started very similar to how a lot of Earth observation data today is actually developing, which is, an organization like NASA in the UK Met Department, in the EU, the European Climate Service Agency, sort of figuring out that they have fantastic Earth observation data. To that, they've actually also going over time. And can this be actually utilized by governments? Can it be utilized at the subnational level? Can it be utilized by businesses? And in what PREP does is take it a step further. You have all of this Earth observation data. Can you then interlay it with local climate change data, wherever local data is available, and also socio-economic data? So there's a context for that information, and then visualize it in an open access map-based online platform. I have a link, but I don't know if we have internet connectivity. So my colleague Devika is here. If anyone wants the tool and wants to actually play around with the tool, you're welcome to. And we can use our own sort of local data and actually show it to you. Globally, the PREP came actually through the NCI and the US Global Change Research Program. But in India, PREP was piloted both in Madhya Pradesh and in Uttarakhand as part of the larger Indo-US government partnership on climate resilience. And in India, it was developed by the World Resources Institute, Acclimatize, and Future Earth. In Uttarakhand, PREP actually uses, like I said, the global Earth observation data, but very specifically the district level vulnerability and risk assessment. So we were able to actually use that information, and sometimes some of this information actually had to be geo-referenced from scratch. And it really depends on the state and how much sort of GIS information they actually put on their sort of government portals. So some of this had to be geo-referenced from scratch, but also state level sectoral data for the 3 sectors we thought would be priority sectors based on conversations with various departments. And I think that's the other thing about climate services. There isn't enough conversation of what the demand is. So really speaking with specific sectors and stakeholders and saying, where do you use weather data? Do you use weather data? Would you be interested in climate data? What is its implication for you? And therefore, what aspect of this can we focus on? And so very specifically, in the state, a specific department head can actually visualize changes in, say, slow onset or extreme events, both spatially, because the vulnerability and risk assessment is actually a composite vulnerability between districts, and over time as well. And these can be combined, like I said, with socio-economic data that we were able to gather from the various departments in terms of water infrastructure in the state, crop yields, or population, and then present indicative trends. I don't think it's actionable just yet, but it does give you indicative trends. I'll skip this, but I'll give you an example of what we actually did. So if you, for instance, you zoom into Uttarakhand, what you do is you overlay historical landslide, and then you overlay this with, this is physically georeferenced data on all the key tourism hotspots. We looked at this and we said, okay, the state is extremely landslide prone. This doesn't actually tell you very much. So we looked at it another way. We looked at the sort of data for the future. So 2050 Uttarakhand landslide risk, but now look, it's a composite vulnerability. So compared to other districts, which districts are actually more vulnerable, and then overlaid that with the annual tourist data. And you can clearly see areas where, you have a large tourist influx, just about Dehradun, likely Mussoorie, which are also extremely sort of landslide prone. Another example, we tried to link the annual tourist data with water resource vulnerability. And this was fantastic because if you actually look, all the major cities where you see a large tourist influx are actually going to be the most water vulnerable. The reason we picked this is because these are the 2 areas where we realized the government was actually looking at new policies. They're looking at a new adventure tourism policy. And for agriculture, they're very specifically looking at promoting hill agriculture. And we tried to see whether these data layers can actually help in some decision-making in terms of the policy on each. I'm going to quickly end here, but I just want to add that it's not just for sector-based policies and projects and mainstreaming where climate information can actually be used. A lot of the incentive for a lot of states to even get interested in doing a climate action plan was to develop climate finance proposals and bring additional finance to the state. And we are seeing this for a lot of the states who are developing the National Adaptation Fund for Climate Change and DCF proposals. They need a clear evidence base. And this really gives you that. And again, the government mandated revision of all of the state action plans. Now you have a chance to actually have a new iteration of this plan that's hopefully more driven and prioritized based on climate data that you actually have.
Thank you, Anu, and thank you for sharing those images from the WRI Prep platform. I think that gives an idea and indication of what happens when you bring and bridge physical climate information with socioeconomic and other political information that's really in the context of making a decision, both at a public and private sector. I am torn at the moment because we are slightly behind schedule. I am the next speaker, and I also understand you must have questions for our speakers up here. So thank you for being patient and holding back your questions, and I'm going to also then ask to hold your questions even further. We are quite eager to have our panel discussion because that will actually be more interactive. I do have a talk on the U.S. Partnership for Climate Resilience, which gives an example of a tool, which is pushing all of these talks further into the tool development. If we are interested in having that conversation, I can be very fast and show you what a potential tool development could look like. Else, we can get right into our panels. Okay, show of hands on a tool. Majority wins, so we'll do it. Okay, so I'll be very fast, and you can always speak with me after the session. My colleague Andrew Bollinger, who is here with me, is also available, and he's also available to show and demo the tool. But I will just give you a quick overview. So several years ago, President Obama and Prime Minister Modi formed a U.S. Partnership for Climate Resilience. And fast forward, here we are. Of course, this work takes a whole lot of people and lots of different organizations. I will skip all the details. This presentation and the slides will be made available. So for those that are really interested in knowing the details, I encourage you to look at the follow-up or please come and talk to me. Okay, so this Partnership for Climate Resilience involved both U.S. and India partners at the scientific level, at the Department of State level, and in India, we worked primarily with IITM, Dr. Ashwini, EPTRI, and TERI, and a number of other organizations that has led us to where we are today. We were informed at the form of the partnership that India has state action plans, and part of the challenge from the first development of the state action plans was the need to better understand and incorporate high-resolution climate models and projections. What do they mean? How do state action planners make sense of them? How can they be applied? How can you actually develop a plan? And then to what Acclimatize has done, which is even beyond that, how do you make sense of it and bring that information to other parts of the departments that have to understand the context of how climate change matters? So we spent a lot of time having a lot of workshops over the past 2 years. This is my 4th visit to India, and it's been just a joy and a pleasure to see the development and evolution of the maturity of the conversations. These workshops began as a very technical conversation. One of our partners, which is Dr. Catherine Hayhoe from Texas Tech University, who is a well-renowned climate modeler and physicist, developed a capability which was more raw in its format, and part of our exercise involved teaching state action planners how to run a climate model and apply it. These workshops evolved as we became more and more familiar with what the needs were of the India state action planners and participants and what we were producing. Naturally, where we began and where we ended in and of itself is a story. So these workshops were highly technical in nature. They talked about different kinds of data sets, different types of modeling techniques, including Cordex, NASA Next, GDDP. There are different model approaches that we discussed. For example, the perfect model from GFDL. We talked about the asynchronous regional regression model. And we did have a lot of workshops that talked about the application context and the sector context, but really they were very technical in nature. So technical that all of the participants around the room actually became quite frustrated because we were saying, download R, do this, download this data, and download the software called Panoply where you can visualize this information and blah, blah, blah. And actually that's quite a lot to ask of a decision maker who really is not trained in hardly any aspects of what this information entailed. And really, we're trying to hit the ground running with the information content from the climate modeling experts and expect our decision makers to just catch up and be ready and available to plug and play that information. We all know that's been quite of a challenge. So one of our partners, EPTRI, actually recognized this frustration and decided to step up. What we found really is that our approach and some of our biggest stumbling blocks was really related to the coding. So thankfully, with a little bit of support and then a lot of support, we were actually able to work with a third-party solution provider called Value Labs and developed a tool. And so what you see at the bottom left is a screenshot of the tool itself. As I mentioned, my colleague, Dr. Andrew Bollinger, who's a climate modeler himself, is available, and we can, as conversations lead further, or please stay with us afterwards, we can pull up the tool and show you what has been done. What made this tool so unique? Well, first of all, you're hitting the ground running. You log into the tool, and what you see is, selection options. Do you want to look at the information by station? Do you want to look at maps? There are graphs and charts that are made available. The user can interact with this tool. Simultaneously, we had WRI working with Uttarakhand and Madhya Pradesh, also working with these two states to extract information that can also be loaded into their tool. And there are two different methods, two different approaches, but the visualization and the hands-on access to the tool that makes the decision maker not spend more time questioning the data and the models, but really just look at the context of how is the information applied was really the goal. So what you see here is, some of the capabilities of the tool. You can, again, analyze climate models at a location. You can observe bar charts and so on and so forth, or you can look at it over the entire region, which are maps, and what you see here is a precipitation map over India. So what are some key outcomes? You could see that while it seems like this was truly planned as part of the partnership, it was actually organic in nature how we arrived. But that speaks to the very important nature of collaboration. It actually also speaks to the very important nature of having the user and the decision maker express their needs and frustrations, interacting directly with the scientific community and all those in between in the value chain that are all part of the problem and all part of the solution. This is particularly a joy for me to share because we always wanted and envisioned the concept of developing a solution, but didn't really quite even have those parameters defined. And it's through these workshops that allowed us to arrive here. And through that process, what we're really doing is capacity building all along the way. Capacity building with solution providers, software engineers, the scientific community, Andrew, Ashwini, Dr. Srinivas, all those folks at EPTRI and I learned a lot in terms of how much literacy is needed, but you also cannot expect all of those folks along the way to understand what a visualization of a climate projection should look like. It's quite a lot to ask of just about everyone. So this tool development is underway. We have robust outputs out of one state, but it needs to have a lot more data for all the other states. It's also a great way to interact with stakeholders. So rather than spending time discussing issues with the data and issues with the projections and limitations and uncertainties, your stakeholders are able to jump right into the conversations of how will this matter? What are the implications? How can I actually make decision under uncertainty? As Anu was alluding to, is one of the harder parts of the problem. So looking ahead, we are working with decision makers and state action planners. We hope to do more of that. There is a desire to have more state-based information embedded within these types of tools, whether it's a WRI prep platform or this one that's actually a collaborative between EPTRI, IITM, NOAA, owned by, all of us in a sense, but really intended for the state decision makers and the state action planners. And I think as a result, looking ahead, we hope to build a lot of engagement capacity discussions because this is just the beginning. And I haven't even touched upon the importance of what this means for a public-private sector collaboration. So with that, I'm just going to jump right into our panel, which is quite interesting, and we're going to talk about all of these components at a much granular level. I'm particularly pleased that we still have Dr. Gupta still involved, so thank you, and we would welcome you to please stay for the panel if you can. Speaking for Saurabh for a second, I regret to inform you that Dr. Attri is not able to attend the panel. However, he was meant to represent perspective from the IMD, but we have two other folks and experts in the room, Dr. Patnaik and Dr. Tyagi. So please, should you have any questions, please don't hold them back. Should you have any expert perspectives, we encourage you to please share. In the room, we have lots of people that are at stake, and your input would be very highly valued. Okay, so our other panelists include Dr. Shiva Prasad from EPTRI. Please come and join us. And thank you to our speakers. Our panelists, please come and join us. Dr. Shiva Prasad, Mr. Abhinesh Goyal, please, from Tata Consulting. Very exciting to have you. We have Mihir Mathur, please come and join us. And I'm simply your facilitator, but please do not let me hog the conversation. This is meant to be interactive, so I will begin the conversation, but the conversation is amongst the whole team here. some basic ground rules for panel discussion. When you're asking a question, please introduce yourself. We spent the first half of our session discussing examples of climate risk, impacts, and applications across India. I invite those of you that would like to have your conversations to please carry them outside. We're here for a panel discussion, so I'm kind of going to have you all focus up this way for a second. But by all means, this is collaborative, but for any personal conversation, if you could enjoy yourself outside. We have lots to talk about, so I will just get right into it. But before we begin with questions, I thought I would give our panelists a chance to begin by offering a few statements, simple and short, in terms of what has your personal and organizational experience have been over the past year in moving the needle or raising the questions or experiencing the issues from your company or from your organization from a climate services perspective. We don't have to define it anymore. And as Dr. Gupta said, we know what that is. We know what the needs are to some extent. But let's just get right into it. We will actually kind of begin with Mr. Abhishek, if that's okay, from Tata Consulting. Okay?
Okay, so good evening, everyone. And thank you so much for having me here. My name is Abhishek, and I work with Tata Sustainability Group, which is a group level initiative to promote the concept of sustainability across the 120 Tata companies. Now, the adaptation as a subject is a rather new one for us. We started working on it only in 2014. Okay, and while we have been working on the subject of mitigation ever since 2005, but adaptation only took our focus rather very recently, and I'll try and give you a couple of examples of what were our drivers for getting into adaptation, and I think maybe then we can go forward in terms of what was our experience going on the subject. So one of the first and foremost drivers that we felt was that we've talked a lot about how we can reduce our impact on environment as a company, but I think there was somewhere also constantly a realization. So for example, we have a company called Tata Tea or Tata Global Beverages, which makes coffee and tea, right? For them, this topic was becoming very much relevant, and from there, that is where the first initial set of questions started as to what is the future of tea. What is the future of coffee? So some of the some of the results that came out initially for us were rather I think not the best, because it seems, and I think there is a report which now says the future of tea. It was done in collaboration with several agencies. Is that a lot of global tea production is going to suffer because of climate change? Okay, so all the people who are tea lovers, we are in for a bit of a not so pleasant time ahead. So that was one of the beginning of this thing, and then we also realized that a lot of our companies, so for example the Chennai floods or the Uttarakhand floods, the many other instances actually kind of made us look into this concept, saying that are our value chains vulnerable to climate change? Are the physical assets that where we exist, are they vulnerable to climate change? And if so, what is the extent to which it is, and what can we do about it? These were some of the initial inquiries that were there in our mind. We then also wanted to extend the concept further into the value chain as to how do our supply chains get impacted because of climate change. But then Tata Group, being a very unique group in terms of its philanthropic approach, 66% of this group is owned by a philanthropic trust, so majority of the profit that we earn actually goes back into the society. And we also realized that a lot of CSR work that we were doing was not really solving problems the way it should be. Okay, it wasn't truly resilient to climate change. So for example, if we are responding to a disaster, that's one of the things that we do. If we are going and building storm shelters for people or maybe if we are going and building homes for people whose homes have been destroyed by a hurricane, are we actually building houses which will be able to take care of the next storm that is going to come, which may be of category 4 or category 5? Okay, so that kind of so we also believe that informing our CSR efforts with this climate change information is also very much relevant. I'll pause here, and these were some of our very initial, I would say, urges or requirements basis which we embarked on this journey of adaptation.
Can we hear some perspectives from Dr. Shiva Prasad in terms of what EPTRI does and some of your
Yep.
own experiences?
So good evening, one and all. So Environment Protection Training Research Institute is a nodal center, and also it is a capacity building of the training center in Telangana, aiming at environment protection. In this pursuit, as a part of this climate action, EPTRI is aiming at developing capacity building programs, and also mainly it identifies the domain or sectoral specific action plans, and also the informational challenges. As we're talking about the NOAs, where we collaborated with NOAs so as to bring out how this critical aspects of the data to be presented to the decision makers in order to move forward. So how we can bring the data as visualization as a tool to make the decision in a proper way, in an on-time decision. So these are the key areas where we are much interested in. The EPTRI is very much keen in moving the projects and decision making to move the projects, mainly as state-specific action plans and also sectoral specific action plans. And we also recently a pilot project being launched in a very drought-prone areas of Telangana, where we call as a climate resilience for the agriculture households. So through this project, we are very happy to share that we could develop some of the portfolio of adaptation strategies for the farmers, mainly for the marginal and small farmers. How can they become agriculture resilient? So households, how can they become resilient due to the change in the climate scenarios, and how we can sustain or we can consistently they can maintain their income so as to meet the challenges being posed by this environment or the climate change. And apart from this, we also look into what are the interdisciplinary approaches, in what way we can bring out the mainstreaming the climate change action. So the climate action as a part of the government, various programs. So as a part of this activity, so my colleague is already here, Shaili Malu. So along with her and also our team is very keen in developing indicators. So these indicators, how they can be used to quantify the impacts. So in what way these indicators are required department-wise, in what way we can bring this action plan into its implementation at a different level, how we can bring the government into an action, how we can come out with some appraisal report for each department so that the climate action and as well as the environmental indicators are the part of this project development. And also we capacity building programs, we look at especially the my domain area, where I look at how the change in the environment, say for example, change in the geochemical cycles of the soil, how we can integrate into the climate change action. So I look at the different profiles, like how microbial flora changes, how the biogeochemical cycle of this soil changes, and how it is integrated as a part of this, what are the data tools what we have as on day today. As one of the objectives we also included as a part of the one project of our DST being sponsored is the strengthening of the climate change center. So where we are looking at the different soil profiles across Telangana state, how the profiles of the fertilizers being used, how can bring down these chemicals and as other fertilizers being used, in what way we can mitigate the impact of such chemicals in this area. So what sort of solutions and what sort of recommendations can be given to the government so as to come up with an action plan to implement or to come up with a policy so as to give a proper direction in this area. So there are the highlights of the EPTI, and also we look at the Green Climate Funds. So, and also we are collaborating with the undertook coalition with the objectives of the Telangana has already signed this, and also we are particular about GCF so as to with respect to the water sector and also the forest sector, where we are bringing this rejuvenation of the forest so as to how it can complement to the urban local bodies as well as the other local bodies, etc. So these are the highlights of our climate action as a part of the Environment Protection Training and Research Institute.
Good evening. I was part of the research project that we did on governance of climate services in villages in Maharashtra. So I speak from that experience of how farmers are using climate services, weather advisories, agromet advisories, and what do they do. So one of the research papers that we published talked about decision-making processes of farmers. And in that, through multiple surveys, we came up with a grid of what are the factors that are very important for farmers' decision-making, what kind of weightage they give to those decision-making factors, under what conditions. Now, that grid is as clear and as simple as some of the model projections that you saw earlier in the presentations. you almost need to run a model to understand how they make decisions. So what we realized is that decision making of farmers under uncertainty is not a simple linear process. It's a rather fuzzy process. Now, how do you attribute your information that you give to them, which is little difficult for them to understand? How do you know what kind of decision making do they do using your climate information? That's a very, very difficult process, the attribution part. So what is the answer here? The answer, I think, has come in bits and pieces when we look at the tools that people have developed or are developing to engage or to aid the decision-making process of people. One of the examples which Saurabh quoted on the project that we did was on the climate risk impacts on the oil and gas sector. What we did there was we set up a system dynamics model which converts the climate projections into economic impacts. So we ran the model for 8,000 hours for 1 year of our refinery's lifetime. And then we simulated saying if there is a 5% drop in your freshwater availability, what kind of operational losses are you looking at, say, in a future year? And if you had, say, 3 adaptation strategies to mitigate those losses or climate events, what would it cost you and what are the cost benefits? Now, if you can convert these models as decision support systems as tools, which are then given to people in interactive forms as mobile apps or computer, just pure computer interfaces, I think the real answer is help people self-advise themselves. The challenge right now is we're trying to advise around 10 crore farmers in the country about what they should be doing in each farm, whereas our climate information that we supply is either at a district level or a block level. Now that's too much of a gap that we're trying to fulfill. Can we enable people to take their own climate informed decisions through development of tools which bridges the gap between climate science and the socio-economic and cultural context that people live in at different levels of literacy, different kind of businesses that they run? It's like informing a pilot about whether the pilot should take off or not. That's not what we can do. What we can tell the pilot is what is the climate or what is the weather condition. And then the pilot is actually taking a self-informed or self-advisory decision. Can we build those kind of capacities across where people can self-advise? And that makes our job really easy. We don't really have to work so hard to penetrate at such a mass level in India, where even the climatology changes, the agrometeorological systems changes so much. So that has been my experience about interacting with people on field.
Okay. Thank you for giving us that first line of perspective from each of your different organizations. I'm torn because I want to jump right into the tool question, but let's get there. So let's begin by getting there and discussing climate information itself. You might argue that climate information is supply-driven today. I will caveat some of my perspectives from the United States, that's where I'm from, but I have spent a little time now in India and having to really understand, how is India addressing the entire aspect of climate services and climate data and information to decision making. So if you argue that some of this information is supply-driven, I would ask the question to our users and to our stakeholders who are really trying to apply this information, what are the challenges when you interact with climate information and try to apply it in a decision context? And then let's have Abhishek begin, because I know you have a lot to say.
Okay, yeah. I thought I had a lot to say. After having seen some of the presentations here, it seems that I think my problems are not mine alone, and also that I guess some people are actually working on it, so which is very good news in a big way. But let me try and put some of my experience behind this. There is something called as the Tata Global Sustainability Council. It's a council of 16 CEOs who sit and who take the decision for the Tata Group as to how we will work on sustainability. And one of the key topics whenever adaptation came up was that they were kind of sold to the idea of that climate change is happening and that it is impacting us and everything, but they were not really clear as to how they can use all this information to take specific decisions, right? And I think we tried to solve that problem by we did a very detailed study for the state of Gujarat. We did the whole set of analysis, right from what would it the different scenarios, the RCP 4.5 versus 8.5. We tried to give them a vulnerability a composite vulnerability index. all that kind of a report was made through, I mean, in-house it wasn't available, so we looked out for external help. But then even then, when we looked at the output, the question that was like, isn't this a little too far away in the future, and isn't there a lot of probability attached to it still for me to be able to convince the board that I need to, we need to go for a 100 crore investment to maybe supplement the power plant, or which is sitting on the coast, okay, or which has an outfall channel which is 2 kilometers down in the ocean. But even if sea level rises by a small percentage, it could mean that the entire power plant operations could be disrupted because the cooling system won't work just because the water level itself has raised. So these were some of the questions, but again, multi-million-dollar questions required maybe a much more deeper and something with a lot of conviction behind it in terms of numbers. And that is where we felt that I think the way climate data is being presented, because of the way it is more likely, very likely, extremely likely, these kind of words then put the decision maker in a very, very difficult position that, what do I do? You tell me, so I'm just talking the pain of the CEO sitting on the other side, that it's a lot of good data, it's a lot of good science, I completely appreciate, but please help me make a decision basis this, right? So that's something which we have been trying to do again, and it's a process. So we also realize that it's a journey. People will have to be first onboarded. People will have to do some small calls, which may not be $1 million calls. It could be some small calls, but once they have better confidence in this, once they are able to either look at some case studies where companies or corporates were actually able to thwart off a particular risk by taking this into account, I think that will help us a lot. Okay, and so I'll rest my case here.
Okay. Yes. Can you please introduce yourself?
Scientist field, and I have a couple of comments or a question, whatever you need. On the Shivas, just I want to know, because in Telangana case you are telling about that there's a huge pesticide and fertilizers use is going on, and you want to analyze those fields, and then you're trying to give some mitigation, how you can improve the soil status, etc. Just I'm giving a very different case of Sikkim. What happened? There was a political willingness, I'm talking, and in 2003, it was decided now there would be complete ban on the fertilizer use and the pesticide use, and that happened the phase-wise, and then it became in 2016 the first fully organic state of the India, and 2018 it was awarded in the Rome that first organic state of the world. Okay. That is how the things goes. Just analyzing those soil types and how you can mitigate unless you stop or at least you reduce. So what exactly my suggestion would be that in any state, or if there is a difficulty to get in entire state into the organic at once, but you can divide the whole state in different parts and start with some kind of the experimental zones, and then you see how it is effective or not. Taking the commercial and the that economy criteria also, so people are not deprived of that economy they are earning, but there is always scientifically there is a little fall and then it goes up in the organic when you adapt. So that is one thing. Second thing with the Abhishek, you're from the corporate world, of course. What I understand, the corporate, at least in India, they are doing wonderful job. Many of the corporate groups, they are doing very well in the field of the environment. A couple of times I was invited by some big corporates like Ambani's, etc. But I feel that their efforts largely based on their own priorities, their joy, their comfort zone. The country needs something different from the corporate. Though it is a corporate responsibility, that that kind of the percentage is there for the investment. But actually, unless you make the kind of the liaison with the sound research organization which are having the proven ground, and maybe with the governments. So it is a kind of the interactive approach that would be more feasible.
Thank you. Thank you for the suggestion, and I hear you on that. I guess the fact that I'm sitting here talking about adaptation itself is action from the corporates. Okay, something which is much larger, something which is much more driven towards creating a world which is where we completely understand, and I think that's a realization corporates are getting more and more, is you cannot earn profit in a society which is plagued with problems. For me to prosper, I need a society which prospers, right? And I think more and more that realization is dawning upon corporates. I guess I'll speak for myself. I think I have fundamentally changed my perspective that while we are in the business of making profits, but the profits will only make a meaning once we are able to create larger prosperity. Okay, otherwise it's of no use.
Just it is a very just.
Can we?
Sorry,
small,
is there a question,
intervention?
sir? Can,
Yes.
okay, because
Should it be just it is a very common. The corporate should spend some percentage of their profit if they are out of their use of the natural resources to the scientific world, to the science researches.
So yeah, I think,
Yes, think about it.
the CSR part is actually guiding that in a big way. Tata Trusts are actually supplementing a lot of scientific research in this country. So that's where we are very actively involved in doing that. But all said and done, there is a lot more which can be done, and I think I will not try to defend the corporate sector on this thing. I think a lot more action needs to be done. I'll stop here. Yes, ma'am.
yes, thank you. Yes, so I wanted to circle back to where you started, which was highlighting some of your challenges and needs. And in the room, you have a number of different solution providers. I wanted to hear from the corporate and the private sector needs first, and then I will transition over to the public sector needs. And we will come back to you in just a minute, Dr. Tyagi, if that's okay.
Where knowing the past trends and the present climate, in next 10 to 15 years, 1 degree centigrade minimum is going to rise, and can't we start doing something concrete?
Would you like me to answer?
Yeah, exactly.
So the no regret scenario is something what we are actually now focusing on, and as you said, we have been working a lot on mitigation. Okay, but from the adaptation point of view, this is where making that small delta, but something which will anyways be the logical thing to do, is what we are looking to do. Okay, and of course the bigger or the more the super magnitude projects is something which is eventually going to come, but we are definitely focusing on the no regret scenario because that is the most commonsensical thing to do. So I completely agree with your point.
See, common sense is most difficult to do it.
Yes.
We all talk out, but until it's a big project report given to somebody, signed by somebody, nobody will listen to you. So it has to be backed with the good science, good part also, and common sense, of course, will work then thereafter. So my point is, do we have such examples? The industry could show that this is what adaptation they have done, so that it becomes good case studies for other industries and other people to know.
So that's exactly, as I said, we are trying to do the same. Whatever CSR work that we are trying to do now, we are trying to actually inform it with this information. We are trying to build resilience in the communities where we operate. Because, see, imagine for a corporate, I am not in the business of creating public good. I am in the business of, creating some returns for my shareholders. But if I look at a little bit further away, when I look at the stakeholder approach, then a lot of people become more relevant for me, and that is what we are trying to do now. It's a departure in the way we have been operating, and that's why I'm saying it will take time, but we are there and we are committed to this. I think. And the fact that we all are here, at least we can find some joint solutions. That will be a very helpful thing.
Could you define what all definite answers you expect from the service providers?
Yes.
So if that could be listed in 10 years, 20, 30 years frames, there will be positively uncertainties and probabilities given to that.
Yeah.
So you can't be precise. Science is not precise in a framework of 30 or 40 years. So you have to start taking decisions based on those probabilities. And there are models which should be able to incorporate those probabilities and the risk associated and the cost associated.
Agree. I think
Yes.
let's.
I'd like to give Dr. Prasad a chance to react, and going back to a number of different things, and the conversation's evolved a little bit, but please share your comments.
Sir, with respect to the fertilizers in Telangana, So this is a context with respect to only, we have already done some experiments related to the farmers where we analyze the different crops of leaf analysis has been carried out. In continuation to that, it is not just that Telangana is using more number of fertilizers. That is not the hypothesis behind this proposal. It is to indicate what sort of the usage of these chemicals is there. It is not that with the hypothesis we are going that there is excessive usage of chemicals. It is there or not, do we want to establish what is the data? So basically. Number two, as a part of this climate mitigation, as you rightly mentioned, your suggestion is well taken. So it should be an interdisciplinary approach. Definitely we are integrating the part of the vulnerability assessment as well as the other aspects of the climate change. Basically we have recently piloted a project on the agriculture resilience, where we have implemented the project in different agroclimatic zones. It is not just based on some area. So we have divided the state into different agroclimatic zones, and also we are coming up with the concept of the climate resilience, the smart agriculture concepts, where we are integrating this aspect into the program, and then we'll come up with an action plan where this mitigation can come out. It's not just one parameter based assessment that we will use this data as a mitigation plan. So definitely, as your suggestion is well taken, it will be definitely integrated approach as to address the issue in the state of Telangana. And we believe that this project, if there's adaptation strategies and implementation now, definitely sir was mentioning some strategies which can be implemented or replicated across the India can also come out of this project. That will be a very great contribution to the part of this climate resilience.
So I wanted to evolve the conversation slightly. In the room, we have a number of different types of stakeholders. We have decision makers, we have public and private sector users, and we also have the scientific community. One question that's been raised quite a lot, whether it's in India or in the US or elsewhere, is really related to, is the current suite of information that is available, so I'm speaking to the users in the room, is the current suite of information that is currently available in a format that makes it easy for you to use it? And if so, we'd love to hear that case study. If not, we'd like to hear about what are the challenges and what can the producers of the information, the suppliers of the information, hear from your feedback and challenges so that we can start making some changes just in information access that's currently available. And then we'll talk about new information. Okay, can you please introduce yourself?
Yeah, I'm Ritu. I'm an actuary. I'm here representing Institute of Actuaries of India. So we are currently in a process of developing an extreme climate index, and then after that extreme climate risk index. So our challenge is that we are doing this research project as a part of our hobby, me and my friend here. So we are not representing any government organization.
Fine.
We are not representing any big corporate, and we don't have any specific need. Like what we are trying to design, it will be for everybody, not specifically for farmers only. For it will be a comprehensive tool,
Sure.
which can be used by any stakeholder. Now, as we don't come from any big organization, and also actuarial as a profession is not that very well known in India. So the issue what we are facing right now is that we are not getting access to the data, because the kind of data we require, it is going to be huge, granular for each station. So we have the what we say. We have the analytical skills, we have the number crunching skills, we have the model in place, but we are not getting access to the data. So,
Yeah. So
Okay.
let's talk about that.
Challenge one.
There's publicly available data, and then there's privately available data. But before I comment, it looks like there's someone else that has some comments.
Yeah, so I work with the urban local bodies, so I'm coming from that perspective. There are two main points that I wanted to raise. One is that, by 2050, a lot of, more than 50% of our population is going to be living in cities, and they are not really incorporated to that extent in, be it the state action plans or the climate model. So I think there needs to be a greater focus on cities. The other is that, there are perception-based, I would say maybe indicators or models that need to be developed, and they need to be integrated with these models, because India is very diverse. I mean, within a state, you'll have 10,000 variations, and probably these kind of models might not be able to capture those. But then the local voices are going to be able to provide better interpretation of those risks and the need for adaptation. So maybe there's a need for amalgamation here. Thank you.
Okay. I do want to come back to tackling the answer to your question before we get to Shaylee's question. So just a minute. Do we want to have the panelists react to where and how do we get that data? Do we have any experts from the data providers in the room that can comment? Or I invite our solution providers and the data brokers to respond. And no response is not an option.
Like in the presentations, you might have seen the word Codex was used, Coordinated Regional Downscaling Experiments. So these are set of freely downloadable data sets of 50 by 50 kilometer resolutions that are available. Then the other data set that was referred to was NASA Next GDTP data, which performed better than Codex data over the Himalayas. So data is there. But the fact is well taken care of. Is that data relevant to all kinds of stakeholders that is available? And that's exactly what she's asking is the scale is an issue for you? Is the format is an issue for you? Is the whole understanding of the data is an issue for you? If that is the issue for you, then science is there to even simplify it. These tools that we were talking about is there to simplify it much better for you.
Right. Yes, please, yes.
That data which is available over there, it's not, first of all, like Himalaya region. The data which I'm looking for, the entire Indian geography. So it's not there. It's huge data. It's huge data. And I'm looking at different components like temperature, precipitation, wind speed, sea level. So each data set is not available there. For each region, it's not available there. I don't think it's possible to upload that much data in a small website. So those kind of granular data, that's not available there. In case somebody wants to continue their research on their own without the help of any organization.
So yes, and I just want to make two comments. One is station-based observation data, which is a historical data, and the other is projection data, which is a climate model prediction and projection data. And if I understand what little I understand about actuaries, I think you're looking for historical data.
Yes. And that 200 years.
Yes, and I want to...
As much as possible.
Yes, so I want to characterize... let me respond quickly. Okay, one, there's some data available publicly and freely. You can, I actually work for the organization that's NOAA, National Centers for Environmental Information, where you can get world data for free, and we can talk more about that. However, it is limited for what we have available for India. For India, I think your question is two things. One is, does that data exist? And second, do you have access to it? And those are two different questions. And so I will pause there because I invite others to respond to that. So it's unfortunate that our speaker from IMD is unable to attend.
Yeah, but I think I remember that when I was beginning with the same set of issues, I think IITM and IMD actually have this kind of data available with them as
Yes.
to what you're referring to. It's a matter of you finding the right person in these institutions and getting access to that data. I think this data exists. It's only a matter of finding it.
Yeah, it's historical information. It's not confidential information. We are not gonna create some. We are not gonna do some terrorist activity using these numbers. So these should not be confidential. These should be easily available. Even for a price, we are ready to give that. But it should be available, and there should be no reluctance in providing that. So I'm not naming the institutions. So I'm not naming, but we had a discussion with one of the organization. They were very reluctant about sharing.
Complaint about data. You ask any researcher, he'll say there is not getting data, and so the point is, firstly, the individual is not very clear what is he looking for. So he asks for everything under the sun, which is difficult for somebody to provide. So be specific. What do you want? You want past 100 years of rainfall data? It is available. It is being made available to everyone whoever wants it. For the research people, it is free, and for somebody, it is a minimal charges. It is there. So data, you should be very clear. You can't ask everything entirely. Start doing your work. Be very focused on one particular element. Show the results, and then more data will come. So see, you have got limited resources available to you. You are expecting that everything should be made available, and you really don't appreciate the complexities of the data. So all these things, you should be very focused what you would like to have, and I'm sure the data will be available.
Sir, we are actuaries, we can handle big data. That's not an issue. But the thing is, the index which we are trying to develop is a comprehensive index. First of all, it's not focused on one component only, like rainfall. Because we are focusing on extremes. It might be due to wind speed as well. We need that data. And to have a proper trend, I need 100 years of data. Without looking at the data, I can't know what is my reference period is, where to find those anomalies, like what is going to be my, in case I have to standardize my parameters and everything. I need entire data. Without looking at that, I can't take the decision around my reference period and what is extreme in context to one particular reason.
So I want to react very quickly to a couple of things. One, it's time, but for those of you that would like to carry the discussion, I invite everyone to stay. I'm available to stay, and I invite the panelists to stay. So we're in a new world and a new paradigm where artificial intelligence, computational capability, the ability to manage big, large data is not the problem. In fact, if you speak to a lot of artificial intelligence experts, they would argue they don't have enough data. And the only way to build more data, and they actually look to the climatological community for large data and big data. I can share with you what's happening in the US as an example to help move the needle. At the world's largest archive of data, we're actually making our data archive available through the cloud services providers. This is happening slowly. We have several successful pilot projects. It is in the hands of the users. It is a paradigm shift. We are looking for this access to enable greater solutions, to enable the analytics that will help inform the reinsurance companies, that will help protect the vulnerable and help private and public sectors make the right decisions on where and when to pull out of a market that's experiencing an extreme event, or how to make good, smart, strategic decisions. It is fundamental to any critical decisions. It requires analytics. I celebrate your endeavors. And so then let's talk about how do we get what we do know. And so for those of you that are solution providers and data brokers, please meet with Ritu, and find some channels to give as much information as you possibly can. For the data brokers and solution providers in the room, it sounds like we need a portal or some solution. I think at the next WSDS, we will have to talk about data solutions. In the meantime, I think, data without the scientific component that explains the climatology and the scientific understandings, how do you analyze this information correctly is another aspect of that. So it's not just data, it's understanding what makes this a good data, what makes it a bad data, when do you throw out a data. It's not a straight statistical exercise as you might experience in other data. So that speaks to the analytics in the room. But it sounds like we have some additional comments, so please, I
A
invite.
quick comment, Jenny.
Yes.
On, I think even a landscape of what are all the players in the climate adaptation space, that itself will be a big, value add to somebody who's as challenged as me on this subject. I think the entire value chain, right from data providers to people who have modeling expertise to people who have ability to convert it into managerial kind of a outcome. I think if we can have just a landscape of all the players, that itself will be a huge help. I guess maybe something like there's a website I remember called The Shift, which is I think at the MIT hosts that website. They do a comprehensive landscaping of various subjects, but I think we need something like a Shift tool for the adaptation world.
Okay, loud and clear. It's a very one. Yes, Shaylee, and then we'll go to Anu.
So my point is that.
Can you please introduce yourself?
Yeah, I'm Shelly. I'm working in the climate change space, and I see the problem of data not more from the historical perspective, but being able to say that why we need that data. Because the requirement of the data is different for different sectors, different applications. If we are trying to address the urban sector, if I want to design a stormwater sewerage which has a lifespan of 25 to 30 years, I think my requirement is different. I can't stick with the same kind of data that we are going to get out of all the analysis. I need to know the peak event. That's what I want to know, so that it does not fail, or I need to know the possibilities of peak events, and is my current system able to handle it, and what we will do. So we need that kind. If I'm going to the farm sector, the requirement is absolutely different. The peak event alone is not important there. The importance is where the paucities are going to come in terms of rain, where the rainfall is going to be high, where we are going to have more heat events. So if you're looking at the urban infrastructure, the requirement is different. If I'm looking at the industry, the requirement is different. The industry needs something very different at times. It is not like this. For the industry, it is that particular factory at times which matters the most. Now, getting data to that level is very difficult. So what is it that will address? Knowing those, so the challenge point is much more difficult. Before we finalize what models or what tools we are going to use, we need to list down and jot down that this model, this analysis, this tool is going to apply to whom, and then take the next step.
Yes. You're assuming that many of your users are literate and informed enough to know how to even provide the requirement. And one of the first things I spoke with Abhishek about is, what do I even ask for? I don't even know.
Articulating my problem.
Yes, so because the user is not able to articulate the problem, it's like the other side which has to, and then get it back to the user in a layman's language, and then together bridge that gap, and then go back and do the analysis.
Sounds like we have to do some engaging.
I'd like to add something. I'm Ashok Raja, young scientist, IMD. The day I joined first in IMD, same problem arised. I told the same thing to my bosses. So, wo data nahi hai, kaga se main kar दूं? And the project which was given to me is flash flood. Imagine, we are in the era where we are not even able to predict proper flood, and we are now in the era which we are going to predict flash flood. Problem is, young people say, like me or like others, whether you want idli or dosa from the same platter, are you going to prepare or are you going to order it? Two chances. Are you planning to prepare everything from your raw data, or you want baked data? That's the only difference now. And to be frank, some of the data, past data, historical data is there. And we did have a constraint in some areas. We didn't have proper data at all still. And we are planning to have that fine rate scale. So that's why we have moved on into satellite, radar, and some data like temperature, rainfall, yes, you do have it. And wind speed, where you need to have telemetry stations, you need to have automatic weather stations, and it should be operational. And 100 years, see, from here, if you go back 100 years, the itna manpower hamare paas tha, like, do we had so much of manpower to take care of all this wind speed in all this Himalayan region, where at snowfall in the mid of January where no persons are even accessible to that area. So we did have some data, but not as we are expecting now. Now I am expecting 3 by 3 kilometer gridded scale global model. No, I need a fine skidded model to predict urban flood of Delhi only. See, that is how it has gone. From 54 kilometer scale, now we have come up to 3 kilometers. We are improving. But the problem is, no, we want everything at a day, like we order. That is impossible. Gradually only it has to take place. And a country like India, where you have now 6,000 heliometric stations and you have at most great scale WRF model, global model, ensemble model, satellite, and we are now accessible to AU MedSat data, NOAA CPC. We are accessing all our data to finecast our forecast. Because this was not happening in the past. Now it's happening. That is why we are able to have all this data on heat wave, cold wave warning, all these things are happening. Otherwise it is not possible at all. In this changing arena, it is not possible to predict everything fine-tuned.
Okay.
One quick comment. While we are talking about data, I would also like to say that data is not always equal to information. So you can have a lot of data and you can worry about it and you can wait about it, but even if you get it, it may not give you the required information. Adaptation is about acting upon information, either that you get through data, through your intuitive sense, or through your wisdom that you have gained through your practices. So when we talk about adaptation, and climate services mainly is about adaptation, all the data that we use also have to make good sense to us for our own actions. And I think once we know that, then the requirement for data also leans down a bit. And then we are very specific about what data we need for what information processes. Specifically when we talk about decision making under uncertainty. So what kind of decision making processes require what kind of data? And can your extreme event index provide that information for effective proactive, for decision making, for proactive adaptation? And then if you start from the end in mind, then the questions become even more sharper and sharper, and we just don't get lost in the maze of data.
Data information expert sounds like he's inviting both of you for a dinner conversation.
Yes.
To help bridge this challenge, because it's very important that you as a user recognize from the science perspective and the data perspective what's currently available and why the other pieces are not, and what's it's an evolving aspect, and I think the community is getting better and better. But yes, you have we'll close out this comment with Ritu, and then we'll go to Anu.
Yeah, so the thing is this only, that there is lots of stereotyping towards young people entering yeah. So, no, I'm not saying that.
We are also relatively young.
So, the thing is, when we are asking for that much data, even we know that data was not available for all the reasons, but in case I have to do the interpolation, I want to fit something towards missing data will be there. Obviously, I need to see that. How would I know?
Fair enough. Yeah, fair enough.
And I have clearly stated which components I'm needing for my extreme climate index: temperature, rainfall, wind speed, and sea level. Four components only, and with clear object fitting the index for the extreme events, and then another index for the extreme risk event, extreme risk index.
We'll take an email, we'll document that as a user need, we'll pass it to our young IMD scientist.
That will be great.
And along the way, you will be asked to participate in engagement conversations to help profile uses and applications of the information, and then case study your experience and document the entire journey so that we can all collectively learn, where the issues are, where we're better, where we're not.
Yeah, we are ready to do that.
Okay.
Given we get the data.
And now let's hear from a consulting expert, Anu Jogesh, who's been doing this and living this for years.
And trying to connect the dots, I hope. I think one of the things that Abhishek sort of raised is very important, and I think he hit the nail on the button. The thing is, for people who are looking for data, and I again, now I'm not just going into climate data, people looking for information on sort of what different governments have done, what specific civil societies have done, to what extent, where is this information actually available, and then sort of trying to map it spatially so you can actually go in and get, but also tagging it to a very clear resource list to connect the dot. This is actually something the Department of Science and Technology has been wanting to do under this National Mission on Knowledge Management, right? And they have funding. I mean, so the real question is trying to piece all of, and it's government mandated, which means you already have states which have to actually collect this information. You already have states that are trying to actually collect this information. So the next step is for the DS to actually have a conversation wherein not just the government, and I think this has been the one big missing gap for a lot of the work that was done on the state climate planning. The local businesses, the private sector was just not included. You've had to have a conglomerate like Tata look at it in one area and they say, okay, now I'm proactively looking at my supply chain. But there are actually enough, not just large businesses and SMEs that are going to sort of get affected. But this map, I call it a map and a compass. You want a map and you want to direct people to what is available, the resource people, but also the amount of information. The other big, and I think she hit the nail on the head, or rather, Jenny, I think you connected that other dot, was different data for different people. We know that this work has been done at the regional level for climate services. There was a big piece of work that I think Practical Action had done, trying to go around and find out what is it you're looking for, not what data you're looking for. What are you trying to actually address? And therefore, what are the kinds of data requirements? You need this big demand side analysis, and I think this is a big pending space as well.
Thank you.
Okay, at this time, first of all, thank you for very insightful and enriching discussions. I had about 8 intense topics for discussion like this one, but I think moving the needle on 2 of the 8 is a significant progress and a significant way for us to summarize. At this point, I'd like to invite our panelists to offer 2 or 3 closing remarks and 1 area of action item or contribution they would like to see, and from whom.
Okay, let me begin again. So I think for me, I think, as I said, this ecosystem of service providers who exist, what are their capabilities, and I think that itself will be a very big starting point for us. The other thing, I guess, is we are also constantly looking for organizations who can help, bring a bit more, I would say, increase the level of literacy on the subject of adaptation itself within our companies. Last year, I made something like a primer on climate change adaptation for my own companies for the consumption of internal people in Tata Group, right? But again, the idea is that we need to be able to, induce people into action. Currently, the way I understand is climate change information is scaring decision makers away simply because there is too much of, I would say, for them, it looks too complex for them to engage with this thing. So I think if it can be simplified in a way that it excites them to make that first baby step towards managing this problem called climate change adaptation, I think that itself will be a very, very big plus for us. And I think for the larger community at large. So.
Sounds like a strategic roadmap.
So,
In
I think.
addition, yeah.
So from the perspective of the EPTI being a training and research institute, so we wanted to highlight on this capacity building with respect to mainly awareness. That is a very important at very subnational and as well national levels. And also what is informational interpretation data gaps. So as mentioned by one of our speakers, and also what exactly exists there is a gap. So where do we have to plug in? So what it needs to be strengthened where? So we have to typology. So we have existing data sets with respect to what we are talking now. But exactly what is required so as to interpret the real challenge. So where we are. So what is a quo vadis? So where are we going? So these exactly pedagogical tools can be brought into an action so as to meet the requirements of decision makers so that the actions and as the projects can be moved forward by integrating the private and public sectors and also encouraging our young generation so as to come forward with some innovation so that we can meet some challenges. That's right.
But the decision makers are totally different between private sector, public sector, government,
Yeah.
and all other sectors.
Yes.
All then it is not possible.
Yeah. Take it. So I think climate science has to be fun. We can't expect people to read up our journal papers and do adaptation. I don't think that's happening. My family doesn't read my papers that I publish. My wife does sometimes. So it has to be entertainment. It has to be really fun. We can't expect people walking on the road to look at your box plot diagrams and say, whether I should buy a house in the next 10 years or not. That's not going to work. So we need to have really good interactive tools on your hand. At the back end is science, at the front end is fun. And it's our job. So it's me who's going to do it with Saurabh and with all of you. The second thing is the basic instinct of humans is to survive. So we are going to adapt, whether we have climate services or not, whether we have data or not. So the future is bright, but unless and until we make living fun, and that's what our ultimate aim is, climate services is not going to be fun for us.
Thank you to our esteemed panelists and to this participants and to the organizers and co-organizers. I'm really pleased with the rich dialogue we had today. I do want to add a couple of things that I heard earlier today, mostly from our science experts who wanted to offer some remarks in terms of what matters to them. So if you'll just allow me. We didn't touch upon this today, but part of the conversation here is scale issues. Scaling to reach our decision makers is a big challenge and opportunity, and scale for the actual data and information itself, the high resolution temporal and spatial resolution data. We don't have enough of that. So there's this tension between, is what we have enough to enable adaptation decisions? Our actuarial expert will say, I need this information at this asset scale by Latin log, by millisecond if you have it. So somewhere in there is, a point of diminishing returns, but there's also a scale issue. And different sectors with different needs have different parameters at different scales. We could talk about scale issues all day long. We're talking about applying assessments. So, in India, you have state action plan. In the US, we have a national climate assessment. We are learning from India how to kind of create a state type of assessment. And I think maybe perhaps India will have a national climate assessment. I'm not sure, but let's see. Assessment is one thing. Taking the information from the assessments and bringing it to the decision makers continues to be an opportunity. So this seems like, it's a big scale of a problem, and for the solution providers in the room, we've got some work to do. I want to go back to one comment that was raised that I personally resonate with. Public-private sector collaboration. We talk a lot about that. Yes, mandates are different, missions and visions are often different, but yet they're totally interdependent on each other. Private sector needs public sector infrastructure, and public sector needs private sector products and services that we all use and consume. Somewhere along the way is a need for investment in the science and the research and the solution providers. Resources can come from any place to fulfill the need, and I think sometimes the need or support can come from private sector, and it doesn't have to be earmarked specifically for private sector good. It can be for public sector good. So doing good and doing well, we believe, does not have to be mutually exclusive. There is room for trusted broker. We need a trusted broker to create this ecosystem of providers. Any takers in the room? I think I see two, at least, both on my panel. So I challenge our trusted brokers to think of creative and innovative and fun approaches to making the information content available. The validity of that information content requires our provider of the information and our user of the information to be available to respond and check and assess and continually develop. At the end of the day, this has been a pleasure for the US team to be here. This is an Indo-US Partnership for Climate Resilience. We've made some progress. There's some more to be made, but as a result, we've had some rich dialogue, and it's going to help inform how we prioritize engagement activities. So I look to all of you to continue to participate in climate information workshops that we will be holding. Partners in the room will be Terry and EPTRI and IITM. So if you don't see information that you're expecting to see in a couple of months, please reach out. With that, I thank you so very much. It's just been incredible. Saurabh and I have quite a long paper here to summarize.